Yes, but we can look at the calendar later. This lesson is on 4.1, on absolute extrema and the mean value theorem.
Where's the intro?
Mr. G Math, right? Coming at you live, right? Okay. That's right, room 7202 right here in UI. 2017, August 30th. Here we go. So we're going to start with some vocabulary to begin with. That's always fun. And then we're going to practice and have examples where we use the vocabulary, and that's far more powerful. So here are some definitions to make sure that we're talking about the same thing when we say it. So what does the word absolute maximum mean when we talk about a function or a graph? Sometimes absolute maximum is also called global maximum. They are equivalent, same words. It is of a function, and this is important, it's the y value that you're looking for. So when it talks about what is the absolute maximum, it's not the full point unless they ask you for the full point. If they just ask you for the absolute maximum, they're looking for the y value. Marianne, I'm glad that you're back. Yay. So, what is the absolute minimum of a function? Again, it's the y value, not the full point. A relative maximum, this is the y value that's the greatest in a local area. Not global everywhere, but it's isolated to an area. It's the highest y value. Well, the relative minimum, again, is isolated to a local area of the function, and it's the lowest y value. When you say the word extrema, it means either maximum or minimum values. So it means both together. So find the extrema of the function means you find both, the max and the min. And critical numbers are x values that we're going to test and see if that produces a y value that's either a max or a minimum. So all of these words we're going to put in context with questions right now, okay? So note, absolute extrema, the candidate test. So in order to find where these y values are, we're first going to find the critical numbers. You know that's going to involve calculus. You know it's going to involve derivatives. You're going to find those y values using those x values we're going to come up with. And then when you look at the group of y values, you're going to pick the largest y value will be the maximum and the lowest y value will be the minimum. Okay, absolute extrema can occur either at critical numbers or at endpoints. So when we have this, we'll have a system down pat where we do both the endpoints we test and critical numbers inside the endpoints where the turning points are. So wherever there's a turning point, we have to test that to see how high and low that turning point is. And we're going to use calculus to find that, right? Those turning points, what the y values are. All right. So let's continue. Relative extrema can occur only at critical numbers because it's not the full thing, right? It's just a local area in the middle. And we'll not consider endpoints when it's relative because we're just talking about the middle somewhere of the function. Okay, here are some examples. So first we're going to look off a graph. This will be the easy part. So, number one, can you tell me what the absolute maximum of f is, that function? So you write it down and think about it. Let me make sure it's over here so you can see the graph. So looking off the graph, what is the absolute maximum? If you think it's complicated, you're thinking way too hard, okay, Jocelyn? You can't put it like that. Did you come up with the number? What did you come up with?
No, 4.
So if you didn't come up with the number 4, something's happening, right? When you look off the graph, where's the highest point on the graph? The whole graph, right? Absolute means you look at the full graph, where's the highest point? What's the y-coordinate there? And the answer is 4. If you thought too hard, something's wrong, right? Number 2. At what x value does f have an absolute maximum? Okay? But it has to say the x value, right? Otherwise, it's just the y-coordinate. What is the absolute maximum point? It asks for the point. So then you give the point. So what's the absolute maximum point? It is negative 4, 4. Do you see that in vocabulary between the top three? What is the absolute minimum of f? Look at the function, look at the graph. What is the absolute minimum? And the answer is so, what is the y-coordinate at the bottom? That y-coordinate at the bottom does not exist. Why doesn't it exist? Because there's a hole at the bottom. Tricky, right? At what x value is there a relative minimum? See the difference? Relative minimum is looking at turning points. At what x values are there relative minimums? So, do you see right here, there's a dip, a bottom here? What's the x value there? So, negative 3, there's a relative minimum. Do you see any other turning points? At positive 1. And is there another place? This one's tricky. Do you see this hole right there? If I looked at this area right in here, right? Is there a low point in that area? Yeah. At what x value? So at negative 3, at 1 and 2, there are relative minimums. Where is there a relative maximum? At what x value? Right up here, right? And what's the x value there? Negative 1. All right, that's looking off a graph.
So the relative minimum means that you're looking at the points in between
the endpoints, correct.
So anything in between.
That's right, where there's a low point, right? Yes.
Why wouldn't negative 4 be a relative maximum?
When x equals negative 4? So when x equals negative 4, it's an endpoint. So when we're talking about relative maximum ends, it's not the ends, we're looking in the middle.
Oh,
Okay? But if it says absolute or global, you look at the ends and the middle.
Oh, okay.
Okay, 7. What does it ask for? The global. All right. And do you notice there's an interval here? That means there are end points. So I'm going to help you through a way to find what that y value is, correct? Okay. Now when it says the word extrema, right, that could include what? Both, correct? It's not asking for, if it said the maximum or minimum, then it would be that. But extreme means both. All right. To do that, first we're going to test the endpoints. So how do I test the endpoints? And what else are you going to plug in? Let's do that. Step 1. You should not need a calculator. The first group of numbers simplify to just negative 1/3, correct? The second group simplifies to negative 2, because negative 1 squared is positive. So together, negative 1/3 and negative 2, because they're the same sign, we can just put them together, and it's negative 2/3. We haven't answered the question yet. We need to find all the possible y values, and then we'll look at them all to see what's the highest number and the lowest number. Okay, plug in 3. Again, you should not need a calculator. We got this? So obviously 27 divided by 3 is 9. 9 times 2 is 18. So put it together. Okay. So we already know of the two options we see, the minimum, right, would be right now, the absolute minimum would be negative 9. But that's the endpoints, right? In the middle, how do we find where the turning points are. What do we use for calculus? Why am I going to take the derivative of f at x? So one of the things the derivative does, we want to find the slope where it's what? 0, horizontal. Because a horizontal slope means that it either changed from increasing to decreasing or decreasing to increasing. So when I take the derivative equal to 0, I'm finding where the horizontal tangents are. In other words, I'm finding the turning points. Okay. It could also be a point of inflection, but we can test that too. So anyways, we're going to take the derivative equal to 0. That's also considered a critical number for me to test. Do you know how to take the derivative of f at x? That's only the power rule. That's the easiest rule there is. What's 3 times a third? And then what do I do with the exponent? Subtract 1, right? Okay. How about negative 2x squared? And then what did I say I'm going to do with it? Because I want to find where the turning points are, right? When we have those horizontal tangents, tell me where the graph is turning. Solve it. I'm not going to do it for you right away. X squared subtract 4x equals 0. I'll tell you in a minute. You have friends, smart friends in your group. The jockettes. Could you solve it? How do you solve a quadratic equation? You factor it. How do you factor x squared minus 4x? It's not a trinomial. We're not drawing diamonds or nothing. Just a common factor, right? What do they both have in common? Now again, we're only finding the x values here, right? Those are the critical numbers. So when I solve this, what are the two answers for x? 0 and 4. If you were asked, what are all the critical numbers? You would say x equals 0, 4, negative 1, and 3. The critical numbers are the endpoints and the x values of the turning points. Did you hear that clearly? What are the critical numbers, right? Turning points.
So then the critical numbers are the basic numbers that we use
to test.
To sketch a basic graph.
You would also use those, but you could use other things too, like x-intercepts and things too, right? But you're finding endpoints and turning points. There's one more layer to it that we're going to do in the next question, which is where it's undefined, is also. So, like if you looked at the graph point at x equals 2 in terms of that, the derivative would be undefined in terms of that, because it's not continuous, right? Okay. So we also have to look where x is undefined for a derivative to also see it. That's the next layer. But in this case, it's continuous, right? There's a derivative everywhere, so we don't have to worry where it's undefined. Okay. So I want you to look carefully, and I want you to think why I'm crossing out 4. I like that. Right. In fact, it's not the word range, but the word, and it's domain, right? From negative 1 to 3. So when we're dealing with x, it's the domain. So the domain interval, 4 is beyond it, right? We're only looking from negative 1 to 3, so 4 is too large. So which is the only x value that I'm going to use? 0. So what am I going to plug in now?
0.
Doesn't take long, does it? When you plug in 0, the answer is 0. Awesome. Now we're going to write a simple little sentence. The absolute maximum, if I can spell that, absolute maximum is, and the absolute minimum is, and you're going to fill in what the answer is. So what would you say? We're looking at these values. What's the largest of those values?
0.
So the absolute maximum is 0. And the absolute minimum is? Did it. So to find the absolute max or minimum, you have to look at the endpoints and the turning points. And you're going to see in the next example, we have to look to see where it's undefined to. And then test those points. Yes?
You would know if it's an endpoint or a turning point, like with what we're just like in there.
Right. So given in the question, if there's endpoints, then that's what you look at. You look at that domain restriction. That gives you the ends. The calculus gives you what's happening in the middle. All right, turn the page. So find the absolute maximum and minimum values of that function, the absolute value of x subtract 2, on the interval 0 to 5. So where's a good place to start? Plug in the endpoints, right? So the x value is 0 for one endpoint, and the other one is 5. So let's start there. You have to plug it into the function. So if I plug 0 into the function, 0 take away 2 is negative 2, and the absolute value of negative 2 is positive 2. We write that answer down. Plug in 5. 5 take away 2 is 3. The absolute value of 3 is 3. There's a start, right? So the first two critical numbers are x equals 0 and 5. How do I find the other ones? By taking the derivative equal to 0 or where it's undefined, right? Now, there's a challenge here for absolute value, right? To see the derivative, we're actually going to graph it. There is no power rule or whatever for absolute value. How would you graph and do a quick sketch of the absolute value of x minus 2? I like moving it to the right, too. What did I move to the right to that matters is the vertex, right? And what shape is it going to look like from there? Good. Now, when you take the derivative to the left of the vertex, the derivative is always negative 1. To the right of the vertex, the derivative is always positive 1. In other words, there's no 0 there, is there? Is there any horizontal tangents? No. What's the derivative at the vertex? And the answer is it's undefined. Why is the derivative undefined there? Because it's a corner, right? A sharp turn. So that's part of it. So another critical value is when x equals what number? 2. So when x equals 2, that's a critical number. It's undefined, right? The derivative is undefined at 2. So not only do we have to see turning points, but also where it's undefined. So not only the first derivative equal to 0, but when the first derivative is undefined. Okay, so the first derivative is undefined here because why? The sharp corner. In other words, the derivative on the left does not match the derivative on the right. They don't agree, so the derivative does not exist. But it's still a critical number. So when I plug in 2, obviously, what's the answer, the y value? 0. So what is the absolute maximum? And what's the absolute minimum?
0.
So why are we plugging in f at 0?
F at 0 we did plug in, and the answer was 2. That's an endpoint.
The derivative of f at 0.
The derivative of f at 0 would be negative 1. The derivative is not 0. In fact, these are endpoints, right?
Yes.
So at 0 up here is an endpoint. 2, 3, 4, 5. And then at 5 somewhere here is also a endpoint. And so when it says what's the absolute max up here, the y value would be 3. And then here, what's the lowest y value? And the answer is 7. 7 is 0. Okay, 9. I have no idea where 7 came from. So, number 9. It's a nice number. When it says to find the extrema, what are you looking for? Good. Go for it.
So same thing as last time?
So they call it the candidate test. How do you do that candidate test? What do we have to do? You test the endpoints. What are the endpoints?
-1 and 31.
And then you take the derivative equal to 0. Also see if there's a x value that makes it undefined.
Yeah, so the non-earnings cancel out, so then the 2 there, so.
So the cube root of -1 is -1, but -1 squared is +1. So when you plug in -1, it's really 3 times +1. I'm going to say it again. Do you see the exponent 2/3?
Yeah.
So you take the cube root of -1. What number 3 times itself equals -1? It's what? -1. The numerator means you square it, too, right? So when you square it, it doesn't stay -1, it becomes +1. And then 3 times +1 is 3, and that's 3 plus 2, right? The negative times the negative. So what number is that at the end? So do you see where I got 5 again? Again, fractional exponent. The denominator is the root, and the numerator is the power. So you do the root first, and then the power. Or you can take the power, the numerator first, and then cube. Either way, it's going to be +1, and then 3 times +1 is 3. -2 times -1 is +2, so 3 plus 2 is 5. How about 3? Ain't happening, is it? So we're going to just leave it, and we'll talk about it in a second. So it's 3 times the... Oh, and that's squared, isn't it? Okay. So 3 times the cube root of 3 squared, and then -2 times 3 is -6.
Isn't the squared with the 3 inside?
It's on the outside.
It's on the outside? Not with the 3?
If I asked you, do you think this answer is negative or positive? Without a calculator. Any ideas? Why?
Because you can't do it like this.
No, all together, like when you subtract 6. So this number subtract 6 all together. In other words, is this first number bigger than 6 or smaller than 6?
It's bigger.
So I'm going to, right? If this answer here was 2 or bigger, 3 times 2, right, would make an answer that's positive. The cube root of what would help me get that 2 there, right? So if it was the cube root of 1, 1 squared is 1, and 1 times 3, and it would give you a negative answer. If it was 8, the cube root of 8 is, and 2 squared is 4, and 4 times 3 is 12, and then it would be a positive. In between, in terms of understanding it, which one is it going to be closer to try to estimate it?
4.
Is that going to give you a negative answer or a positive answer? I'm going to let you keep thinking about that. Let's move on to the derivative. You can take out your calculator and see if it's positive or negative. See if you estimated it correctly. Oh, come on. But you know what? You're also right. You could put the 2 inside and it would still be correct. And if it was on the inside, 3 squared would be 9, right? And the cube root of 9 is bigger than the cube root of 8. This is going to give you a positive answer. That's going to be helpful as we move forward here. All right, next. Can you take the derivative using the power rule? What's 2/3 times 3?
2/3 times 3.
2/3 times 3. 2. What happens when I subtract 1? Close? Good. And then the easy one, negative 2x, the derivative is negative 2. I'm going to make that equal to 0 and solve for x. Let's start easy. Add 2, and what's the answer? So if I add 2 and then divide by 2, if I isolate this, what's the answer? Add 2 and divide by 2, it is 1. How do I undo that exponent? All you have to do is the reciprocal. What's the reciprocal of negative 1/3? Negative 3. So both sides to the exponent negative 3. I want you to notice the left side reduces down to just x, right? X to the positive 1. 1 to any exponent is equal to 1. Is positive 1 in my interval? Between negative 1 and 3. That means x equals 1 is a critical value. So if I plug 1 into the function, what answer do I get? Remember, 1 to any exponent is equal to 1. So 3 times 1 is 3. And then negative 2 times 1. So it's 3 take away 2. So the answer is 1. Let's keep going. There is one more critical value. I wonder if you can see it. It's the x value that makes it undefined. Do you see the derivative? I want you to know that a negative exponent means, where does it really belong if it's not a negative exponent? It belongs in the denominator, right? A reciprocal. So another way to write this would be 2 over the cube root of x subtract 2. And the only reason I'm writing it that way, it's obvious what x value would make it undefined. That would be, no, what x value would make it undefined? Look at the denominator. 0. So if you plugged in 0 for x, that would be undefined. So what's another critical number we have to test? 0. If you plugged in 0, it won't take long. What's the y value? 0. So can I circle all the critical values and y values that went with it? I know. It's okay. So, first the easy answer. What's the absolute maximum? 5. Thank you. So of all the y values you see, the absolute maximum is equal to 5. The absolute minimum. That's not negative 6. That's 3 times this ugly stuff. Subtract 6. And we said that answer is what? So that means the smallest number? So the absolute max and the absolute min, it's still calculus, right? It's still the toughest class you're going to take in high school. So we're going to still challenge ourselves to know that. So the absolute max is 5 and the absolute minimum is 0.